Today's lab will be similar to the Biogeochemical Cycles lab, as we will be working in the Indian River Lagoon. However, today we will be focusing on seagrass habitats. Seagrasses are a flowering saltwater plant that can be found in shallow areas of the lagoon. They are an essential part of the ecosystem as they provide nursery ground for juvenile fish, habitat for shrimp and other animals, and are an essential part of the endangered manatee's diet. In just 2.5 acres of seagrass, you can find up to 100,000 fish and up to 100 million invertebrates. They also add dissolved oxygen into the environment. Seagrasses are considered an indicator species. This means if the seagrass is sparse and unhealthy, it may be an indication that the environment as a whole is unhealthy. In addition, if the seagrass is abundant, you are likely to find an abundant and diverse amount of animals. Today we will be conducting a seagrass survey within the Indian River Lagoon. Scientists use surveys to gauge ecosystem health and aid in conservation. They can also point out problems that may be present within the environment. Environments can be impacted by a wide variety of factors, including improper garbage disposal, exposure to chemicals through the use of pesticides, herbicides, and other fertilizers, improper sewage disposal, and even nuclear fallout. Not only do these factors negatively impact the environment directly, but they may lead to longer-lasting secondary issues like the increase of carbon dioxide, flooding, soil erosion, changes in ecosystems, extinction, and climate change. The Indian River Lagoon itself has been impacted by some of these negative factors. Specifically, the lagoon is often subjected to nutrient and chemical pollution, which leads to algal blooms as well as the presence of harmful bacteria. This in turn can lead to animal and plant death. Today we will be collecting water quality, sediment, and faunal abundance data to determine if the environment is healthy. While you would need to collect data over a long period of time to make any definite conclusions, today we'll give you a snapshot of the health of the environment. For water quality, dissolved oxygen saturation is normally between 5 to 10 milligrams per liter, salinity is between 25 and 35 parts per thousand, and pH is around 8. However, small deviations from these values don't necessarily mean the environment is unhealthy. For example, a lower salinity could be caused by rainfall. To measure salinity and pH, we will be using a refractometer and pH meter, which you should be familiar with from the Biogeochemical Cycles lab. However, I'll quickly go over how to use a dissolved oxygen meter. So we have a dissolved oxygen meter here. This part here is the sensor that will actually go into the water, and this is the screen that will give you a value. So it's very easy to use, quite similar to our pH meter. You simply hold the button to turn it on. So once the screen turns on, you want to put the probe into the water and just kind of gently stir it. And the screen should settle on a number in milligrams per liter. And that's it. We record that number, rinse off the end of the probe with the fresh water, make sure everything is dry, and then it will be placed back into the protective covering. While scientists typically analyze the chemical composure of sediment samples to determine their health, you can also look at size to get a general idea. Typically, smaller particles hold excessive nutrients and less oxygen, so an overabundance of smaller particles may be indicative of an imbalance within the sediment. We will be using the same tools that we used during the Biogeochemical Cycles lab, which you can see here. Typically, to collect faunal abundance data, a seine net is used that looks like this. One individual will stand at each side of the net and pull it tight so that the bottom is angled out in front of the top. It will then be pulled through the water at a fairly quick pace so that any animals that are swimming in its path can be scooped up to be examined. Since I'm the only person physically participating in this lab today, you are actually going to be collecting the faunal abundance data yourself using a virtual seine program. This program has been built using historical data collected by students in the past. I will be going out today to collect the sediment and water quality data from a patch of seagrass. I will be specifically marking the area I want to measure with a bamboo pole so I can make sure the data is coming from the same location. So let's go outside and get started.